Hello everyone and welcome to Unit 3 of this course on Introduction to Programming. In this set of lectures, I will be talking about the structure of programs in the language C, and in particular dive a little bit deeper into variables and operators and how they are defined and how they are used and why they are used in the first place. So, as opposed to what we have been doing so far, where we were looking at an abstract computer, now we will start diving deeper into actual C programs. Now, one thing to keep in mind over here is that I will be sort of switching back and forth multiple times between C programs as well as the presentation, and as a sort of natural side effect, what's going to end up happening is that you will be presented with full-fledged C programs, possibly with keywords or statements or syntax that you are not yet familiar with. So, and that sort of has to happen because in order to get a complete syntactically correct C program, there might be things which it's not always possible to cover before you actually see them for the first time. So, if there are some parts of the program that you do not quite understand to start with, feel free to ignore them and concentrate on the parts that are actually being discussed, and the remaining parts should become clear as you proceed later. Keep in mind also that you do not learn programming from a book, you do not learn programming by watching videos, you learn programming by programming, right? So, part of what I am trying to do over here is also to sort of make sure that when you see these programs, go ahead, try them out on your own, try making changes, try making errors, try making mistakes in the way the programs are written. That will teach you about what does and does not work and how to go about improving the way that you write programs. So, the outline of this set of videos is going to be like this. First, I will be talking about the programming environment. I will then go a little deeper into the structure of a C program, then go a little deeper into a specific topic, which is the concept of variables. Why do we need variables and how do they relate to data types? And the other topic that we will be looking at in this set of lectures is related to the concept of operators, right? What are operators? Where do they fit in to the concept of a C program and how do we use them? So, we are going to start with a discussion on programming environments. Okay. So, what I mean by a programming environment requires a little bit of explanation. The way that you would go about writing a program is, first you need to have an idea, right? There has to be a problem that you are trying to solve, and presumably you want to write a program in order to solve the problem, right? Otherwise, why would you write a program in the first place? What that means is that that idea needs to be specified in some way, right? What is it that you are trying to solve? What are the sort of the parameters of the problem that you are looking at, right? This is usually called a specification. Most of the time it's an informal kind of specification. It starts out as an informal specification, right? Somebody might come up with a problem statement saying, hey, let me write a web browser. Now, of course, the first person to write a web browser could not have called it that because at that time the notion of a web did not exist and the concept of a browser did not exist. So, they had to sort of take terms from other things that they were already familiar with and say, okay, we want some kind of a program which will draw a window on the screen, which will take HTML as input and render it, right, make it display in a certain way that makes it easy for us to understand what that HTML corresponded to. So, that is your informal specification to start with. After that, you start going into details. What kind of input? How is that input going to be provided to you? What happens if there are errors in the input? How should the display be handled? How many colors do you assume are there on the screen? What kind of rendering mechanism do you use on the screen, right? All of those go into what we would like to call the specification of the problem. Some of them are at a very high level, right? I want to take HTML and I want to render an output. Some of them are at a fairly low level. How many colors does the screen have? How big, what is the resolution of the screen, right? So, not all of it needs to be handled right away, but in order to start writing a program, one of the first things you need is that idea. And this preliminary documentation, the specification, usually does not require a computer, right? It could just be done with pen and paper. Nowadays, of course, there are computer based tools that help you to sketch out wireframes or concept documents or what the the application should look like, right? but those are secondary. The core idea behind it is what primarily matters at this point. Now once you have that, actually you start going a bit deeper, right? You start getting the actual architecture of the design, right? What should the memory layout of the system look like? What kind of data structures do you need to define, right? So let's say that you are once again going with a web browser. You need to have some way by which you are reading in data from a file. You need specifications of how that file is going to be presented to your program, right? Is it going to be just something on a file system? Are you going to assume that it's coming in directly on some other input mechanism? What do you do with it, right? Do you read it in as just a string of bytes and put it somewhere in memory, or do you structure it in a certain way, right? What kind of intermediate structures do you need in order to parse out or break up the HTML so that it starts to make sense, and you know which parts, for example, need to be displayed in bold and so on, right? So there are a lot of intermediate data structures and a lot of intermediate planning that needs to happen. Once again, closely related to the core idea of the program, except that now you are actually starting to get into the details, right? In fact, some of the concepts that I mentioned earlier, such as how would you render on the screen and what kind of resolution your display has, would probably fall more under architecture than under the idea, right? As you can imagine, these are not very clearly cut or clearly separated boundaries, right? You can have quite a bit of argument over whether this belongs under the idea or the architecture. Most of the time that discussion does not really matter, right? What does matter is how do you use that in order to plan the design of your program. Alright, so far as you can see, there is no computer anywhere in the picture, right? All of this is probably happening with pen and paper. Now comes the coding, right? You have already decided what kind of data structures you have. By this point, you should have decided what language you have. Of course, in this course, we do not really have a choice. We are going to be using the C programming language, but otherwise you might actually have a choice, right? Deciding what kind of programming language to use. To a large extent, that comes down to a matter of personal preference, because pretty much all languages are mutually equivalent, meaning that something that can be done in one language like C can also be accomplished in Java, can also be done in Python, can be done in assembly language, right? It's just that the level of difficulty or the degree of difficulty that you will face when you try doing it in different languages may differ. Some languages are very well suited to certain kinds of programming or solving certain kinds of problems, whereas others are better suited for other kinds of problems. But what matters is once you have got everything else in place, you actually start coding. Now what that coding actually means is that you need to write a program, right? We usually talk about it as write a program to solve the problem. Now what do you mean by write? Are you actually going to take pen and paper and write on the paper? No. In this case, what we actually have in mind is that you are going to be using a computer based editor, right, which is essentially an application which presents you with sort of a blank page, so to say, and anything that you type using your keyboard should come up into that editor, and you can then of course format it, move things around, save it in a certain way, in such a way that this becomes useful for or rather it conveys some kind of meaning to the computer, right. So that program, the editor, is going to be one of the key components that we are going to be using extensively as we move forward, right. Another common term that is used over here is called the IDE, right, or an integrated development environment. Now IDEs are a little bit more than an editor. In other words, an editor is only one component of an IDE, right. IDEs help you to do a lot more. To some extent they may help you with some parts of the planning of the architecture, right, because they may have some documentation tools that allow you to do that. But more importantly, they have many other kinds of features, right. For example, when you are writing large programs, they scan through the rest of your program and find out where certain functions are defined, how to use the functions, what are the parameters expected by the function. They can generate documentation for you. They can help you with debugging, right. So there are a lot of things that happen when you actually go in for an IDE. You don't need an IDE, right. It is entirely possible to construct the equivalent functionality of an IDE by using small separate programs, right. And again it comes down partly to a question of personal choice, but also to some extent you need to be aware of the components of an IDE so that in the scenario that you don't get the IDE that you want, you are not completely stuck and don't know how to proceed. The second thing is, by sort of knowing what are the component programs that go into an IDE, it makes it a lot easier for you to switch from one IDE to another if needed. Okay. So the coding part is something that we will be looking at in a little bit more detail, and you will be using a lot of throughout the course. And finally comes the running and debugging part. If you have an IDE, once again the running and debugging will be, there will be special sort of features in the IDE that help you with that, right. There might be like one button that you press which compiles your program, right, because after all, what are the steps that you need to do in order to run a program? First you need to write it, create it as a text file, then compile it. That compilation, as we saw earlier, is the part that actually converts a text based program which is human readable into a set of machine instructions that is computer interpretable, right. Now that converting program to code is one of the key steps involved over here, and apart from that, the thing that you want to do is to be able to observe the running of the program. What happens as the program runs, right? Can you actually observe the different parts of the memory and see how they change when the program is running? That might be too much detail for a lot of programs, but there will probably be scenarios where you at least want to see certain kinds of variables in the program and say, hey, I want to know when they change or when they are being affected, right. So that's observability. Once again, for the first part, which is converting the program to code, you need a compiler. You typically need some kind of a shell or a console, some mechanism by which you can actually run the program, right. For those who are used to graphical interfaces, usually you think of just, you double click on a program in order to run it. That actually triggers a whole lot of other steps behind the scenes. Over here, we will also be looking at what's called the shell, which is essentially an interface where a text based interface where you need to type in commands, right, and you will be using those typed in commands in order to trigger the execution of a program. And the next thing is, there is also this concept of a debugger, right. A debugger is a specialized program that can interface with the program that you are trying to run and can actually allow you to halt the progress of your program and identify certain possible bugs, or if it does not behave the way that it is expected to, then you can stop it at any specific point and look inside it. You can observe, right. All of these are tools that you will need to sort of get used to as you proceed, right. So as we can see, the components that you are going to require for actually using the computer in order to write a program would include an editor in order to actually write the program, a compiler which takes that program and converts it into your machine code, a console or a shell, right, and this is something that is best explained by actually experiencing it, right. You see what it looks like and you get a better idea of what it means. The terminology itself comes from the early days of computing, when there was actually a concept of a console, right, a physical device where an operator would sit, and the operator would then be responsible for feeding data into the computer or observing the output, right. Nowadays, of course, what we usually mean when we say console is just, it looks like yet another window inside the computer. The main point to keep in mind over there is the functionality remains what it was 60 years ago, right, which is the console is where we can provide inputs to the program, and where the program interacts back with us, it gives us back the output. And the last but by no means least component over here is the debugger. Okay. Now there are multiple different ways of implementing this. Those of you who are already familiar with perhaps IDEs like Visual Studio or Code Warrior, Code Composer Studio, if you have been doing anything with embedded systems, the Arduino IDE, right, all of those are examples of IDEs that some of you may be already familiar with. What happens in those scenarios is you are usually given an application, right, something that you download and install onto your local machine. Now instead, for the purposes of this course, we are going to be taking a slightly different approach. We will be using this particular website, which is called Replit, right, and the name of replit is, well, the concept of REPL, right, is something that comes up a lot in certain kinds of languages, primarily interpreted languages like Python, right. And REPL actually stands for read, evaluate, print loop, right, and it's sort of a, it was a very common way, or it is a very common way by which you go about writing and debugging simple programs in interpreted languages. But replit itself, it started out like that, where it just provided you with a nice web-based interface where you could do this. But replit.com provides a lot more, right? It has the facility to actually have, you can create your own programs in multiple different languages, and with those languages, essentially it will allow you to, it will provide you with all the facilities that we have talked about over here. You get an editor, compiler, the console, debugger, everything in one package. And since it is web based, it means that you can also technically access it from anywhere, in principle even from a tablet or even a phone if it comes to that, right. The only problem you are going to face is the screen is really tiny, right. Apart from that, you can actually do your programming on a phone if needed. So what I am going to do now is to switch over to the replit interface and walk you through some of what you need to see and understand over there. So this is the website. Let me momentarily take this out of full screen mode. What happens is that you will notice that there is actually this URL over here, replit.com, and that the replit.com, the URL is how you actually access the website itself, right. For now, that's pretty much all that you need to know about it. Rest of it I am going to be discussing in terms of how we would go about accessing it. Now, when you get to this website, the first thing you can see is on the top right hand corner, there is either a sign up or a login. You can either sign up with your own accounts, or there would be, you can probably use your Google accounts in order to actually create an account for yourself, right. All that does is it means you don't need to remember another password, right. What I have done in this case is I am actually logging in with my regular Google account, which I have already logged into on this machine. And you can see over here that the screen essentially shows you multiple different things. On the left hand side, there is a navigation pane, right, which one of the options over there is this thing that says my repls, right. So everything in replit is called a repl, right, and the reason it's called a repl, like I said, is because of that concept of the repl as a way of writing and debugging programs. Now, when we write C programs, you are not really in a read, evaluate, print loop. As we will see, what you need to do is actually write the program, compile it, and then run it. But that's okay. In this case, we are just going to be using the same approach out here. Now, once you choose your repls, you can also go and create folders just to help you to sort of organize the kind of repls that you are creating. In my case, I have created a particular folder for C programming, and I have already created a few repls out here, which I am going to be walking you through, right, at least like showing you some of them. If I want to create a new repl, what I would do is essentially on the top right hand corner, there is a button that says create repl, and it allows me to choose from a set of templates, right. And as you can see, of course, there are many over here. I do a lot of Python programming, so it automatically picks up Python as one of the examples that it's going to suggest to me. Not just me, it turns out there are a lot of people using replit actually do a lot of Python programming, right. A lot of other people also use it to build web pages or web apps, right, which is why HTML, CSS, JavaScript is yet another template. If you want C, you can just type in C, and you should see that C comes up as an option that you can choose for creating your new repl, right. Once you have chosen that, you can give it a title, right, and it comes up with a dummy title name on its own, right, something which is globally unique and cannot be confused for anything else. But it's probably better that you just type in a name that you can remember and understand more easily later, right. So what I'm going to do is just go ahead and create this repl by giving it a name dummy, right. Once I've created it, it goes through this whole process, and now we can start to see some more interesting things. You might have noticed over here on the right hand side pane, a message came up that said booting repl, right, and effectively what you now have in front of you is a virtual computer, right. Of course, this is running on an actual computer somewhere, and of course you are using a real computer of your own in order to access it. It could be your phone, it could be your tab, it could be an actual laptop or a desktop. For our purposes they are all computers, right. Remember, all that a computer really needs is that central processing unit plus memory plus whatever peripherals, and they are all substantially the same. Okay. So when it says booting REPL, what has actually happened over here is that somewhere on the cloud in a data center that is run by Replit, right, it may be somewhere in Google Cloud or Amazon or wherever it is, we don't really know. What has happened is that a virtual machine has been created and is temporarily allocated for your use. Okay, so that is, and that virtual machine, that virtual computer is the one that just booted up. Now in the middle, right front and center out here, you have the big the screen that essentially shows you the editor. Okay, so this component out here, this with the white background and with some text written on it, and this blinking cursor that you see out here, right, this line over here on line 1 that keeps blinking on and off, that's the cursor. This portion out here is our editor. That's the part that's actually going to be used by us in order to write our programs or type in our programs, right. There are a few useful things that you can see over here. One is that right there on top, it shows you the name of the particular program that you are, the file that you are editing, right. In this case, it's a file which was automatically created by Replit when I created this particular REPL. It automatically gave it the name main.c. Okay. Why is that? Once again, this comes down to a little bit of convention, right. You don't have to name your main program main.c, right, but Replit does that by default, because along with creating this main program, it also puts in place a few other programs for you which actually turn out to be quite useful. In other words, for compiling and running the program, it automatically provides some assistance. Okay. Now if you didn't want any of this, you could have essentially, chosen a blank Replit to start with, and it would have given you full control over what kind of files get created, and most of the conventions that are being followed over here would also have been left out, right. To start with, at least I would strongly suggest you just go with the standard templates, but look around, right. I mean, feel free to explore, feel free to try out different things out here, and you should be able to get a better understanding of what are the different things that can be done with the Replits. Okay. So what else is there in this editor? You can see that on the left hand side there are these line numbers, right. Line numbers are a good useful way of sort of identifying where you are in a given program. You will notice that there is this small downward looking V shape out here, right, sort of like an arrow, and if you move the cursor over it, it basically says fold line, right. This can be useful when you are writing programs, because if I click on it, it essentially collapses a lot of the code, right, and hides away a lot of the complexity. When you are writing large programs, this can be very helpful, right. So for now I am not bothered about that, it's a small enough program that I can go ahead with this. So this is what my program looks like at this point. Okay. On the left hand side, right, all the way out here, you have a list of files, right. Main.c is the only one that shows up right now, except that if I go onto this 3 dot symbol out here, I can also ask it to show hidden files, and then suddenly a whole bunch of other files also start appearing, right. Anything without an extension, just like main over here, is in this particular case turns out to be an actual executable, right, not anything. The next file over here, the make file, is something specialized. It is sort of a configuration file that we use in order to tell the system how to compile our program. Okay. Once again, for now we will ignore make files. All of these things, how to navigate in a file system, how to sort of manage these kind of compilation techniques, to some extent we will be looking at them as part of this course, and to some extent they will also be looked at in a system you will probably need to go into a Linux system administration course, not exactly system administration, but at least the shell commands course, in order to understand that. There are some configuration files out here. For the time being, just ignore everything, right. Go back out here and say, okay, hide the hidden files, don't bother, right. Just all that we need right now is this main.c. It also shows you a bunch of tools on the bottom left hand side. Once again, for now we are going to ignore everything, right. One thing that we will be using later is this one marked as debugger, that will turn out to be quite useful for us later. But apart from that, we are mostly going to just ignore everything that we have over here. In particular, you might notice that there is this option called ghostwriter, which may be something that some of you want to explore or play around with. Well, one of the things that does is it automatically helps you to write code. We are in the era of ChatGPT, right, where ChatGPT can probably give us code for solving most problems that you are likely to come across. Needless to say, that does not help you, right. Using one of those techniques or using the ghostwriter over here is not going to teach you how to write code. It will neither teach you how to write code, nor will it help you to understand why the code is executing the way it is. So even though those tools are available, right, and it is difficult for us to absolutely forbid the use of those beyond a point, as far as the course is concerned, technically you are not allowed to use those techniques. You are supposed to be writing your own code, okay. And please, I strongly suggest, do not get into these starting to use these kind of techniques like the ghostwriter or Copilot from GitHub until you have developed a good amount of familiarity with coding of your own. Once you have confidence that you will be able to write the program on your own, then feel free to look at other kinds of techniques in order to speed up the way that you implement a program. And needless to say, in this course at least, you are not expected to use any of those to solve any of the assignments. Once again, going back to the editor, you will find that at the bottom it also shows you some information, right, like for right now it shows where the cursor is, right. So you can see this blinking line over here, and it says that that's on line 6 and column 2, right, because we are using what's called a fixed width font over here, that is to say it's like a typewriter, right. Each character over here occupies a fixed amount of space on the screen. Therefore, the number of columns should align up nicely, right. The kind of font that you use over here, as long as it is fixed width, you should see a nice display which looks clean. You might also notice that the text over here has got a number of different colors in it. The colors are not part of the C programming language, the colors are part of the editor, right. So the editor is putting those colors in place in order to help you to quickly draw your attention to which are the keywords, which are the function separators, where are the syntax errors in particular, right. All of those are things that the editor can help with. Now finally, on the right hand side we have the console, and if you click on the next tab to it, there is something called the shell, okay. So what is this console? Like I told you, the purpose of the console is that anything that I type in here will go as input to the program when it runs, okay. That's assuming that my program wants to read something from the input, right. It's quite possible, for example, this particular program is not going to be reading anything from the console, okay. On the other hand, anything that comes out of the program will get displayed over here on the console, right. So that's basically what the purpose of the console is. Let's try it out with this particular program, right. What does the program do? We will look at the different components of the program a little bit later, right. But for now, the main thing that you need to, intuitively what you can understand is this hash include, leave it aside, it's what's called a header, right, which helps you to sort of set things up for the program. This int main, this particular line over here is essentially declaring a function, right, and in this case the function's name is main. And it turns out that when you are writing a C program, you have to have at least one, not at least, exactly one function whose name is main and also has a specific kind of input parameter definition and an output specification, right. That particular function is what the compiler will take and make the entry point of your program. What do I mean by entry point of the program? Remember, after compilation what happens? Your program is going to get loaded somewhere in memory and the program counter has to jump to the start of the program, right, has to be changed so that the flow of execution jumps to the start of your program. this function main is what the operating system takes as the start of your program, right? And from here I might have many other function calls or some other way of jumping to other kinds of parts of the code. In particular over here what I will do is I will call yet another function whose name is printf, right? And you will notice that in this, the moment as far as replit is concerned, the moment I click on printf, it puts this pop-up over there showing me a little bit information about the function that I have, right? It basically says write formatted output, and it also tells me a little bit about the definition of the function itself. In this case what I've got is I've got a statement saying printf hello world, right? This is one of those, it started out as a simple way of learning how of introducing people to the concept of programming, and has become a meme in itself, right? Everybody who starts with any new program, the first thing that you need to do is write hello world, and the reason for that is simple. It makes sure that everything that you want is in place. Your editor is working properly, your compiler is working properly, your mechanism for running the program is working properly, the computer is able to interact back with you, it's able to give you back information. All of that is very nicely encapsulated in this one short program. And finally there's a return 0. Once again ignore this for now. What matters is that you remember that main is also is a function. What are functions? We will be getting to those later. The important point is it does something and it returns a value, okay? And in this particular case it just returns the value 0. So what happens if I go up here and click on this button run, right? Behind the scenes what is going to happen is on the replit server the program will get compiled, it will get converted from this .c text that we are able to read into a set of bytes which is machine code. It will be combined with some other functionality which the operating system provides in order to create what's called an executable program, and finally the flow of control will be transferred to the beginning of that program. When that happens, what should appear is that it actually calls this function printf, which hopefully should cause this string out here, hello world, these characters to appear on our console. So let's try it, right? If I go and click on run, you can see that the first thing that happens is it prints out something called make -s, right? And you might be wondering what's going on, what is this make about? Like I said, ignore it for now. It's related to that file called the make file that we saw when we looked at the hidden files out here. What is important is all those steps of the compilation and linking in order to create the executable happen behind the scenes when I run that make command. After that you will see that there is another statement out here which says ./main, right? So what does ./main mean? It essentially I am giving the name of the program to run, right? Since my program was called main.c, my output is going to be called main, right? That's how the make file, the compilation process works in this case at least. The / is necessary for now, right? Because what it's telling you is run the program main which is present in the current directory, the current folder that you are in, right? And the current folder is given the abbreviation dot. Okay, dot is sort of a short form that we use in order to refer to the current folder in which we are. So when I type ./main, it prints out hello world. Okay. Now if you want to go a little bit deeper into this, click on the next tab besides the console, right? And what we see is right now it shows us a little bit more. What it says is, there is this line out here saying tilde/dummy, right? Once again, in order to fully understand this, you probably need to spend more time with the Linux system. For now I am going to give a high level breezy overview of what it is, right? But it is worth spending a little time on it in order to try and understand how these things work, right? Because a lot of the compilation process that you need to do from a command line, for example, will sort of assume that you need to do this, that you are familiar, that you have basic familiarity with how this works. So tilde/dummy is the name of the folder or the directory in which you currently are. Okay, this slash symbol out here is used in order to separate the parts or the different components, the different names of the files or folders that are present in your system, right. For those who are using a GUI based system like a Windows or Mac, or for that matter a graphic interface to Linux, you would have seen that there's a file explorer which essentially allows you to create folders, and inside those folders you can create more folders, and at some point you can also create files. That's basically what's happening here. Tilde is the name of one folder which comes by default. It's what's called your home folder, right. Inside that, replit has already gone and created another folder called dummy, and inside that folder dummy there are a set of files. One way of finding out what those files are is to go to the shell and type in a command like ls, right. So what ls does is it shows you what are all the different files that are present over here. It's sort of similar to the file explorer that we saw on the left hand side, except that it's a command line based way of looking at the files, right. What you can see is there is a file called main.c. There's also a file that has been created called main. How did that happen? Well, we compiled main.c when we clicked on run, and it created a file called main. There is a file called makefile out here. Like I said, we will be looking into that later. And there's a file called replit.nix out here. Right now all that I can say is just ignore it, right. Nix is a particular way by which Linux based systems, certain Linux based systems can be configured in order to install packages that are required in order to compile or run a particular software. Replit makes extensive use of Nix in order to install the right kind of packages and the right kind of compilers and so on that you need, and do it in a way that makes it reproducible. That is, the next time you run it, you will get exactly the same results. For now, the best thing to do is to assume that replit has taken care of creating the right Nix file for you. You don't need to make any changes to it. What you are concerned with is only writing the code for main.c. Right? Now the interesting thing is, at this point, right, I mean clearly you have more access to what is present on the system than what was in the console, right. In the console, anything that I type will go in as input to the program, right. Whereas over here at the shell, what can happen is that I can actually type in that command that was given at the console, right, /main, and I'll find that it does exactly the same thing as what happened on the console. Why is that? Because when I execute a program from the shell like this, the shell effectively acts like the console, right. It provides inputs to the program, and once you are done with them, it can take the outputs of the program and display them for you. Okay. So this was a sort of overview of what the replit interface looks like, right. What you will be doing is writing a lot more programs, primarily using this interface, right. Although of course any of you who are used to other kinds of IDEs, feel free to use those, except that for the assignments we will be primarily making use of replit, right. It provides a good enough interface for most purposes. There are no absolutely compelling reasons why this cannot be used for your programming, for the kind of programs that we are going to be doing in the course at least. So you should be able to do everything with this, right. Like I said, the best approach for now is anything that is not clear to you to start with, just ignore it and come back to it later when you actually want to understand why something worked the way it did.